In this video, I'm going to show you how to visualize Wyvern Hyperspectral data easily using the HyperCoast package. So I just implement edit support for it yesterday, and in this video, I'm going to show you step by step how to do that. This is the hyperspectral data here, visualized on the map, and you can click your mouse on the map easily to look at the spectral signature showing here in the lower right corner, and you can inspect vegetation, water, urban, anything you like. Also, upper right corner here, you can see the toolbar. After you click the spectral signature, if you want to use it for classification, for example, remote sensing image classification, you can click the button here, and then you can save this one to a computer. So you can save it as a CSV somewhere. Just click save, then you're good to go. You can open it. You're going to have two columns. The first one is the wavelength. The second one will be the in this case, it's the radiance value. In some other hyperspectral data, it might be reflectance. So I'm going to show you step by step how to do that. If you're not familiar with Wyvern, it's a company. It's like producing hyperspectral data. The website is wyvern.space. You can go to the URL, and basically it produces hyperspectral data at 5 meter resolution up to 31 spectral bands. So it depends on the sensor. Some of those, I think 23. The later one like have over 30 spectral bands. They provide these some of the open data. If you click the link here, access open data, it will take you to the website. So here it actually provides a spatial temporal asset catalog that allows you to see it. So you can click the STAC browser, then you'll be able to see by industry, for example, by spectral bands range, and also by year. Or you can do it just by location. So it's very nice that they provide this kind of the overview of what the imagery are available. You can also upload a polygon, for example, Geospatial or Sapphire, to see what kind of data intersecting with your area. So it's open. I can zoom to any location here. This one is for example, the covering New York City. So you can click, then you will click this view in STAC browser, it will take you to the website. So here you'll be able to actually see the data. You can visualize it here directly. So this is the kind of overview, what it looks like. It covers the area, and you can click this link here to take a look at the basically the URL. You can also download the data if you want to. And this is how you search and find the data. But how to actually visualize that, because the data set is pretty big. Each data set is couple gigabyte, and if you use HyperCoast, it will make it really easy. You can visualize the data interactively. You can also download the data, and then you can inspect the spectral signature. If you're new to the package, you can install it using the pip install on your local computer, or you can also install it on Google Colab. So for this tutorial, I'm going to show you. Let me clear the output. Step by step how to utilize that. First, you need to install the package. So just pip install HyperCoast extra. So because some of the dependencies kind of an optional dependency, so you want to install it. Once you're done, you can just import the package. So there are two ways you can utilize the data. The first way is to just visualize that. So you don't you want to take a look at the data before you try to download it. And the easiest way would be to just get the URL. So like I said, you can go to the website here, the STAC browser, if you click the link. And so this one will show you similar to what I did earlier. You can download the data, so click the download button, and then you're going to pop up a dialog allow you to download it to your computer. So you can just select, for example, here, give a file name. So the file extension is .tiff, is the same as TIFF, so TIF. And once you download the file, then you'll be able to open that in desktop.js. But if you try to open it in QGIS, it's pretty slow because it has a lot of bands, and also the file size is 3.43 gigabyte. It's pretty big, so desktop.js usually cannot handle that very well. So later I'm going to show you actually very efficient that we can do that using Python. Here, the key information you want to look at is the GSD, so the ground spacing distance. This is basically the spatial resolution. 5.26 meter resolution is pretty high, and it has 23 bands. On the left side here, you will see the description, basically the wavelength, and also look at this node data. Later you will also need to utilize the node data information here. And there are additional metadata here on the right side if you want to learn more. So for this imagery that we are looking at, it was acquired in 2024, June 8, about 1 year and a half, 1.5 years ago, but it was created in August 2025. And we're going to use this dataset to visualize that. So first, what you need to do is to get this URL. So upper left, on the left side here, click this button, copy URL. So you can find any imagery on the Open Data program. You can go anywhere you like and then just find the imagery. Then just click the link. So out here, open. Then all you need to just click this one, then copy URL. So this is a direct URL, or you can just download it. Either one is fine. So just copy the URL and then you can come to here. Just in the notebook, replace this one with your URL, and that's it. So once you set the URL, the next step is to just create a map, call this egg code layer function, and that's it. So you're gonna pass in the URL. Under the hood is going to use the t-tiler endpoint, my t-tiler endpoint to visualize the data. This sometimes can be a little bit slow because the data set can be pretty big, and if the t-tiler endpoint is very busy, you might not be able to see it. But take a look, now we see this imagery directly here on the map, right? Very, very cool. And this is a 3.43 gigabyte data set, but we can load it. If you zoom in, you might need to wait for a couple seconds. It's actually loading the tiles, so it's requesting all the tiles on the fly. If the t-tiler is busy, then this sometimes might not work. But you can also download a small subset of the dataset. I already extracted a small dataset. This looks like a bit slow. Let me see if it works. So I can also click the mouse or to get the pixel value. Like I said, if it doesn't work, you can skip it. And let's go to the next one. I extracted a small subset, so it's easier to process. This one, I think it's about 350 megabyte. It's a little bit smaller compared to the original dataset. It's still getting. Let me see if it works. Okay, so I already downloaded the dataset, and so the next step is to call this function read Wyvern. This one allows you to read the dataset as an Xarray dataset. So in that way, we don't need to load all the data into the memory. It's much more efficient. So let me just run this one, and then run this line of code. Here you will see the output, and this is what the Xarray dataset looks like. Wavelength 23, so I have 23 spectral bands. X means basically how many columns, Y means how many rows. And so this is a much smaller one. If you want to see all the wavelength information, you can click this button here. Then you will see all the spectral bands. So this is all the 23, the wavelengths of all the 23 spectral bands. You can also look at the coordinate. All the data that they provided is actually WGS84, so it's latitude, longitude. It doesn't really have a projection. So if you want to reproject them, you can. But in this case, we're just going to visualize them. And so there are a couple ways you can do that. Like once you have the imagery, you might want to see the spectral signature for a particular location, or you might just want to see one particular band. If that's what you want, you can use the Xarray selection. So dataset.acl select, and then you can pass in a number of bands, or you can just have one. So in this case, I just want wavelength around 780, and you might notice here we don't really have 780, right? So, and this is why you want to specify the nearest. That means if this one doesn't exist, it's going to find the nearest band with the wavelength similar to what you're specifying. We specify 780, so the closest one here would be 782, just 2 nanometer difference. So once you provide the wavelengths, then it's going to subset. So this one give you a small subset, just one spectral band. If you click this button right now, you only see array 782. You can also extract multiple. Let's say you want to maybe just extract 3 bands for classification, then you can provide a list here. So I can provide a list, and then maybe near infrared. The other one here maybe 700. Okay, the other one 600. So you can provide a list, then it's going to basically subset into 3 bands. So this is very handy that if you just want to get a subset. Next, let's plot a spectral signature. If you want to look at the spectral signature of a particular pixel, right? If you already know the coordinates for the location that you want, you can just use this function filter Wyvern, passing the Xarray dataset, give the location. So the latitude and the longitude, you can provide any location. If this within the imagery, is going to get the pixel. If this outside the imagery, it's going to find the nearest pixel. So, and lastly, we want to specify return plot equal to true. That means we want to see the plot directly. So this is what it looks like. And look at this. So it's from band 1 all the way to band 23. And this is probably something maybe water pixel, because you can see the near infrared is all very low. But if you look at the vegetation pixels, then it's going to be near infrared going to be much higher. And this is just like for if you want the precise extraction, you already know the location, you can do that. Return plot equal to true, it's going to give you this plot. But if you set as false, it should return yield as an Xarray. So here you will be able to see all the value, the location here, right? The wavelengths, and you can get 23 values, wavelengths. So this is what you, wavelengths. Oh, it doesn't show you the, this one just show you the coordinates. So it's the value is inside, basically you can return it as a parameter. So you're going to get 23, basically it has 23 pixel values. And this is why it's being used to plot this plot here. This is how you can get the data programmatically. Later, I'm going to show you how you can actually do it interactively, so that you don't have to worry about getting all the pixel values manually. So there are 2 ways you can visualize the data. One is the single band visualization. Very easy, just create a map. We also add a base map here. Then just call this function add Wyvern and passing the Xarray dataset, specifying which wavelengths you want. You can also have the indices. For example, I just want to visualize 1 spectral band. And then the minimum value, the maximum value, you can also specify a color map if you're only visualizing one spectral band. Lastly, we want to add a color map. So the color map is something that you want to correspond to the minimum and the maximum value that you are specifying here. And lastly, we give a label. Actually, this is radiant, RADIANC, not really reflectance. So just run this one, and then it might take a couple of seconds. See, now we have this imagery loading on the map. So this is just one single band. So this is band 23. You will be able to see on the lower right corner here, give you also the color bar. So you can see the basic value. Blue means low radius. Basically, you can kind of roughly equal to reflectance. So that means this is in the near infrared band where spectrum. So all the water actually absorbs the light. But for vegetation and others, you will see it's kind of red color. This means very high. So it kind of reflects the light back to the space. And you can zoom in here. You're going to see more details. So this is how you can visualize just one single band. But if you want multiple band, then you can do the same thing here. Also add Wyvern. But instead of providing just a single wavelength, you can provide a list of wavelengths. So in that way, it's going to select multiple bands. But for the minimum and the maximum, the no data is kind of similar. The only thing that we are doing here different is to add the spectral. So this one allows you to add the toolbar that can visualize the spectral signature interactively. Let's run this one and see what happens. So it's a bit similar, but right now we're using basically multi-spectral band, and this is why you're seeing this one kind of a false color composite, because we use 799 and then 679 and 570. If you want to see this individual band, you can go to the website here and look at this one. On the left side, you'll be able to see the spectral signature. Oops, let me move this to the left, to the right. So these are all the wavelengths, right? So 503 and then 510 all the way to 800 something. So this is near infrared band here. they have all these spectral bands. So all you need to just figure out, get this number. If you already know the band, then you can get this one. Or similar to what the source code we provided earlier, we have those 23 wavelengths. So you're welcome to actually also get the basically get any wavelength numbers in here. But you will need to know which one is near infrared, which one is red and yellow, something like that. But once you have this toolbar here in the upper right corner, then this is where you can start inspecting the spectral signature. So just click your mouse on the map anywhere. You'll be able to see the spectral signature here in the lower right corner, right? So this is just one spectral signature for the 23 spectral bands, and you can stack them. If you only want one, for example, you just want to see individual spectral signature, you can click this button to basically just show you one, and then so every time it's just going to show you one spectral signature. So this is a single spectral signature. Or let me clear all of them. I can also enable this one. Click this button to enable that. Now you can see multispectral. So I can click here in location like with all the vegetation. You can clearly see the spectral signature in the near infrared wavelength. They are all pretty high, and this is just what we expect from multispectral data, hyperspectral data for vegetation. If you click water, you're going to see the decreasing trend because water observes the light in the near infrared spectrum. So this is why you see the one decreasing. You can get more pixels if you want to. Also, you can look at urban pixels. So these are all kind of a high bright area. And for the entire spectrum, you can see the reflection is pretty high. It's even higher than the vegetation, also in the red and yellow spectrum. So if I click multiple here, they look pretty much similar. You can look at the rows. These actually observe kind of a darker color, but for buildings, it's very distinctive. And this is how we can actually use the spectral signatures to classify the imagery into different classes. So of course, when you are clicking spectral signature, you might want to just do one class at a time so that you can use it to create training data. But I'm just showing you here, I can click multiple locations. Once you're done, you can click this button here, upper right corner, just click this save button, and then you can just save this one somewhere to your computer here, and then just click save, then you'll be done. After that, if you want, you can open this one on your computer. So if you want to see where they are, then I can, let me do it here. Oh, I don't, oh, this one is on a remote computer, so I can actually, I cannot see it, but I can show you here. It should be under here. So this is the file that has been downloaded to the computer. If you open it, you're able to see the basically all the pixel values. The first column is the band, like index from 0 to 1, and then on the right here, you will see for each column is one pixel, one location. Also, you can see the latitude and the longitude here separated by space. So the first number is the latitude, the second number is the longitude, and then you get 23 pixel values. If it depends on how many columns you have, how many points, then you're going to have multiple columns. So this is how you can export the spectral signatures for your location very, very easily without having to write any line of code. Let me clear all the output. The other one I want to show you is that it allows you to change the band combination. So this is the one that actually right now using, for example, first color composite. But if you want to change to something else, you can click this button here. Then on the right allows you to change the band combination. So you can change it easily. For example, I need to change to something like this and click apply. After a couple seconds, you should be able to see the new visualization. It should work. I haven't tried this one. If it doesn't, there might be a bug. Besides multi-band combination, you can also do a single band. So just like what I showed you earlier in the one above. So this is just a single band that allows you to specify a color map. It should not take this long. I might need to look into that. I haven't tested this one when I edit the functionality. So anyway, this is how you can visualize the data interactively using HyperCoast. Super easy. And HyperCoast actually support many other types of hyperspectral data. You're welcome to check out the website to learn more. It support a lot of NASA missions and also the Planet Tanager hyperspectral data, and also the latest Wyvern hyperspectral data. So this is how we can visualize data. I will look into the bug here maybe and see what's the issue. Okay, so that's all for this tutorial. I will see you in the next one. Take care.